This YouTube is for EE160, Programming for Engineers. This is Chapter 5, Part 2, so we are continuing to talk about functions. So we're going to talk about the random number function, and then we're going to do some examples and use our functions to do more complicated programs, programs that use recursion to make the calculations, and then we're going to learn about a structure called enumerations. So anyway, moving on. So I want to review for a moment the last YouTube where we introduced functions for adding structure to your programs, and I want to point out a few things just to for you to recall on this new YouTube. One is that you have to have the function that you define. In this case, it's called square. You have to make a declaration for it, and when it's for a function, it's called a function prototype. So before I ever entered my main program, by the way, you can do it in the main program, but before I entered my main program, I made kind of a declaration, but it's called a prototype, and I said int square, and int is the type of argument it would have, with semicolons at the end. Now, down below, outside my main program, is where I actually defined the function called square. The function called square takes an integer parameter, it does its calculation, it returns an integer back to the main calling program. Within this main calling program, I said, well, a equals 10. I assigned a variable a, the value of 10, and then I just print the value of a squared. So over here is the function call to the function called square, and the value of a gets passed by value, which we'll learn in a moment, into the function. The function does the calculation and returns the result up here, which gets put in that printf statement. So when you write your own programs, all functions that you define must have a description. So it's a line comment. Before every function that you define, describe what the function does. In this case, returns the square of an integer. Sort of like you have to have our preamble at the beginning of the program, all functions must have a description of the function required. Good programming practices. Now, this slide is titled Scope, so let's talk about what scope means. Scope is the time period in which a variable exists in the program when the program is running. So for example, when main is running, a exists in this program. A does not exist outside of the main program. A does not exist in this function called square. X exists in this function called square. And so let me just show you, I'll illustrate that for you. So here's the program that I just had a clip of. It's saved. I've already compiled it, so I'll just run that program. And there's the answer. Not very exciting, kind of what you expected. But let me show you what happens to illustrate what scope is. So I'll go back to this program. Clearly it printed the value of a here. But can I print the value of x? Let's see. Percent I. Let's make it look proper with proper indents. Oh. Okay, so we want proper indents in here. Okay, did that look right? Yeah, I think that's right. The value of x is whatever, and then supposedly I'm going to pass x into this printf statement. And you know you defined x down here in the square function, so let's see what happens. I will recompile it. So I got a compiler error. X is undeclared, first use in this function. So it does not like the value of x. It doesn't even recognize the value of x. Even though just the line before I called the square function, and the square function has an x in it, but outside this function, x is no longer recognized. So the scope of x is within the square function. That is the scope of x. Okay, so now we know that that doesn't work. Let's take that out. What if I want to see the value of a? So the value of a is, now remember, a is already defined up here in Mint, in the main. A is equal to 10. I call square. I pass a to the function. But let's see what happens. So let me save that. I will go back and compile again. So now I have another compiler error. It says a is undeclared, first use in this function. Now remember, I am in the function of square right now, but a is undeclared. A is unrecognized. So the scope of a is within the main function. A does not exist outside the main function. So when the program goes over here and calls the square function, a no longer exists. So hopefully that nicely illustrates your the concept of scope for you. So let's talk a little bit more about some of the things that happen in functions. So Section 5.8 talks about header files. As you know, right now when you write a program, you have this include statement, and you're including this header file called standardio.h, or maybe you're including math.h. So those are directives to the compiler of what things to include in the program, or what things the program can have access to, really. So let's talk a little bit more about the header files. So every C standard library has an associated header files. These header files contain the function prototypes, definitions of any data types, definitions of constants that the functions might need, such as pi, and macros we'll talk about in Chapter 13. You can even write your own header file, and we'll do more about that later, but just to let you know, if you wrote a header for the square function that we just did, and put the square function somewhere else in another file, you would include a header file with this type of statement. The syntax is a little bit different when it's your own header file versus one of the C standard libraries. So let me show you where these header files actually exist. I did the path right there, but I'll show you on my computer. So I am in my C drive, my SIG164 folder, and then I go to, I think it was user. No, it wasn't user. I suddenly forgot which one I just said it was. Oh, it is user. So I go to my user folder, and then I look under the includes. And so down below is all of the header files that you could include at the top of your program. For example, here's math.header. So I'm going to open it up. So there's the math header, the math.h file. It has some definitions. It has way more than you probably know what to do with at this point. But it also defines has the function prototypes for all of the functions that we have access to, and then it has definitions of a bunch of constants. There, for example, is a definition of pi. Some other definitions of constants that the functions could be using, and somewhere in here is a definition of the function prototypes are also in here. I'm scrolling. Well, anyway, you can take a look. You can take a look at. Also notice. Oh, here is a function prototype for. I just found one of them. There's lots more than what you get on even on your list. Okay, arc, the arc hyperbolic sine function, sinh function. The extern means it's available outside of this program, and the arguments are all double. In the math.h library, all the arguments are double. So anyway, you can look at standard I/O, you can look at whatever function prototypes you want, but I just showed you where they are located. Okay. Whoops, back to my... So let's look a little bit more about what happens when we call a function. I have an example right here. Value 1 is 4, value 2 is 6, and I call a function called average, and the result of average gets stored in a variable called result. So when I call average, what actually happens is that a copy of value 1 and a copy of value 2 are actually placed on a special place in memory called the stack. And so value 1, copy of value 1, copy of value 2 is placed on the stack, and then the function, when it's doing its thing, has access to the numbers that are on the stack, and it does its calculation and it returns its value back. So the stack is a special memory location, and you can think of it sort of as your textbook says like a plate of dishes. So the first thing that gets pushed onto the stack, let's say we push 2 things onto the stack, and then when things come off the stack, it's called popping, and the top item comes off first, the next one comes off next, like a stack of dishes. So this is called LIFO, or last in, first out. So that's this thing that's happening with the functions, where the arguments are passed into the function. This is called pass by value, because a copy of the actual value gets used by the function. There is also another way of passing arguments called passing by reference. C doesn't really pass by reference, but later when we learn about pointers, it will be like we're passing by reference. So passing by reference is kind of a dangerous thing to do, because it allows this calling function to modify something, modify the value of a variable somewhere outside this function. Like it could allow this function down here to modify the value of value 1. This is a dangerous thing in programming. You don't want to do that. So value 1 stays value 1 here, and this function cannot modify it. This function can use it and return a different value, but it cannot modify the value of these values up there. So that would be a pass by reference, and we'll talk about that more in a later chapter. Next section we're going to talk about is random number generation. There are many reasons to generate random numbers. I'm sure you can think of just gambling in video games, for example, use random numbers quite a bit. So random number generation is accomplished by a function called rand. So this is one of our built-in functions. Rand is contained in the stdlib library, and here's the header file for it so that you can use it. So you have to do an include statement with stand_lib, as well as your standard I/O, which means input output. So the function rand returns an integer between 0 and rand max, which is a constant that's defined in the standard library. It has a minimum value of like, it depends on your microprocessor, but there is a minimum value of it. Oh, I forgot, 32,000 I think it was. So I wrote a little program. I called the rand function. I generated 20 random numbers. Here were the 20 random integers, and here they happen to be on that particular calling of the rand function. So so maybe I don't want to use gargantuan numbers. Maybe I just want random numbers between 0 and 6. So here's an example. It's actually from your textbook. I'm going to generate 6 random numbers, 20 random numbers between 0 and 6. So let's look a little bit about how this happened. This is just a for loop. So the structure says, I call this function rand, and then I use this % and a 6, which means I'm scaling this rand function to only give me the numbers 0 to 5, which are 6 values. This is called scaling it, and 6 is the scaling factor. But I want the numbers 1 through 6 because I'm simulating rolling of a dice. So I add 1 to it and I get the numbers 0 to 6. So I ran this program and I get these values. And I have a little note here to myself to show you what happens when I run this program repeatedly. So I am going to show you what happens. Let's clear this off. So I think it was program number 11. So yeah, so there's what happens. Now I generated my my 20 random numbers. Oh, let's point out a little thing. This little part right here, this is just to format it. So if the count is divisible by 5, I begin a new line. So when I hit the count being 5, I'll begin a new line. When it's 10, when it's 15, it's 20. So I formatted the output nicely like that. So take a note of that little if statement that's putting the values out to the screen, or spaces out to the screen like that. Kind of a neat little thing for formatting. There is more than one way I could have formatted my output. So back to, I was going to show you what happens if I executed the program again. So I'm going to execute it again, and I'm going to execute it again, and you're saying, wait, those numbers are repeating themselves. They don't look very random, do they? They look like exactly the same numbers all over again, even though I called the rand function. So it turns out that the rand function is an algorithm within your computer that generates what's called a pseudo-random number. And it generates it the same every single time, with an exception which I'll show you in a moment. But if you just call the rand function, it's going to generate the same thing every single time. It's the same algorithm over and over and over again. It generates from a number called a seed, but the seed has not been changed. So every single time you're getting the same result. So if you wanted to write a program to develop a game, and it's some random game like flipping of a card or something like that, in a way you could fix the game because you know what the random sequence is. So I'm going to run a different program right now, and I'm going to run this program 60,000 times, because if it is truly random, it should converge to the numbers 1 through 6 occur with equal probability. So let me run, I already compiled that program. I'm going to run it 60,000 times. This is example 12, I think it was, from your textbook. It takes it a moment. So here's my numbers 1, 2, 3, 4, 5, 6, and how many times they occur when I've ran this program 60,000 times. And let me show you that I've run this program 60,000 times. Here's the program. So I made these variables called the frequency of 1 through 6. Here's my loop, which is running 60,000 times. And then I have a switch structure to determine whether it was a 1. If it's a 1, I add to the frequency 1 count. If it was a 2, I add to the frequency 2 count. Case 3, I add to the case 3 count, etc. I should have put a default in there. That's not good programming practices. And then finally I display the result. Here they used just some spaces for formatting. So this is like the indent. The number 1 prints, and then I've given 13 spaces for an unsigned int because I've declared everything as an unsigned int. So that's this program. It's actually in your book. It just looks prettier when I have it in Notepad++ and I have the colors. So standard IO and standard lib are included up there. So if I run that program again, takes it a moment. Oh my gosh, I got exactly the same distribution of the numbers. So again, this is showing you that I'm only generating a pseudo-random sequence. It's pseudo-random because it is random-ish, but it's predictable. It repeats itself, so that does not make it truly. If it repeats itself, it's not truly a random sequence. So how do we fix that if we truly want a random number? So we fix it by seeding the random number function. So this is where you give the algorithm that the computer is using for the random number function, the rand function, you give it a number to start with, and it computes its algorithm and spits out all its random numbers. Rand by itself starts with the same number over and over and over again, but if I can give the algorithm a different number to start with, I will get a different sequence of random numbers. And so that's what this example shows you. The new function is called srand, and srand will seed the random number function or the random number generator. So in this particular program, I get a number from the user. I store it in seed. It's some integer from the user. I store it in a value called seed, a variable called seed, and then I call srand with the argument being the value of seed. And that will seed our random number generator. And now I'll go through and print out, in this case, the first 10 random numbers. And every time I run this program with a new seed from the user, I will get a different result. And I think I already compiled that. Let me just check real quick. Yes, number 12 is already compiled, so I will run it and show it to you. Oops, it's number 13. So if I enter 5, I get that set of 10 numbers. If I enter 6, oops, enter seed 6. So I can see that now that I've entered a different seed for the random number function, that I get different results each time. Well, it's not always practical to add a enter a new seed every time you want a new sequence of random numbers. That's not very practical. So this is how we get away, how we fix that problem. We fix that by, let's go to my next program. Actually, I'll show you how we fix it. I'm going to change it in this program, in the current program. So I've done another include up here, and there's a library called time. So I included the header file so I can have access to the functions in the time library for C. So I've put this new include up here. I am going to block comment out this section here, and I am going to add a new command, which will be using the time function right here. I'm going to put it on. I just have it from a different program. I'm going to go through my loop 10 times, but each time I'm going to go through the loop, instead of right now, I will get the same answer, I will get, let's fix that. Right now I'll get, every time I execute this program, I will get the same 10 random numbers if the seed is the same. But what I'm going to do is call srand. So I'm going to call the time function, which is going to get the time from your computer, and the time from your computer is constantly changing, right? Every second it's changing. Actually, it's fractions of a second. So it's going to access the time from your computer, and that's going to become the seed for the srand function. So this is not exactly the perfect way to do it. Let's do it this way. I don't like it that way. I'm going to put it here. So I'm going to call it, and then I'm going to print 10 numbers out, and then every time I run this program again, it'll automatically get a new seed. And let's just confirm that. I have to recompile it. No. Do I need the stand? Unsigned in. Yes, I have to use the standard, so I will. That should compile. No! File not recognized. File truncated. Well, that's a strange one. Let me just fix that real quick. This number. Oh, I know what I did wrong. You guys probably saw what I did wrong. And now I can run it. And I can run it again. And I can run it again. And I can run it again. And every time the result is different. This is what we want. We truly want to reseed every time so we get a new sequence of random numbers. So now we're going to do an example that also introduces some new things, in particular a data type called an enumeration. So I'm not a gambler, so I had to spend a little bit of time figuring out how to play this game. This is the game of craps. So basically you have 2 dice to roll. If you roll a 7 or an 11, you win. If you roll if you roll a 2, 3, or 12, you lose. And in between, the number you roll, let's say you rolled a 5, that's called your point, and you roll until you match that or get another 5, and then you win. But if you roll a 7 before that, you lose. So we need to program this game. This is the example in your text. But before we look at the actual program for this game, I want to explain the new data type that's in it, because it's a little bit harder to follow in the text example. So our new, oops, I skipped a slide. Our new data type is called an enumeration, and the keyword is enum, and it's a data type. So we have this structure, this data type, because in programming you may want to have a variable that will store a value, like we've been doing all along, but it can only take on a very limited set of possible values. And I have an example here, not from your textbook, of an enumeration called weekday. So this is the structure of it. It begins with the keyword enum. This is the tag, and notice I give it a capital letter. That is part of our programming style. The name of the enumeration starts with the tag starts with a capital letter. So weekday, and in this case I have a list of the names of the enumerator. So there's 7 of them, but this is the value corresponding to Monday is 0. The value corresponding to Tuesday is 1, 2, 3, 4, 5, 6. So this list here is a list of the names of the enumerators, but the value of it is an integer. So the compiler will assign a type integer to each name. It turns out that Monday will be assigned a 0, and Tuesday will be assigned 1, Wednesday a 2, etc. So an enumeration is an integer data type, and by default enumerators start with 0, 1, and 2 and continue. And there you can assign it to be differently. So I'm not going to worry about that right now. So I could assign Monday to be a different number if I wanted. Once you declare an enumeration, you can also declare a variable of type weekday. And remember, we had variables of type int, variables of type double, whatever. But now we can declare a variable of type weekday, and we can initialize it. So here's an example where I initialized it. So it's an enum, data type enum called weekday. And the variable name is today, and I've initialized it to the value of Thursday. Here it is in the whole program, just with the weekday enumeration that I created. So I declare my enumeration. I declared a variable called today, and I initialized it to Thursday. And then I run my program. My program is simple. I just print the value of today. So notice when I print the value of today, remember the value of today is an integer. and today is a 3 because Thursday is a 3 in my list. So when I run this program, it will output today is 3. It doesn't output today is Thursday. So then, just for the fun of it, I did a different printf and recompiled, and I tried to make it output a string. No, this doesn't work. I didn't get a compiler error. I actually got nothing because my format specifier for the output doesn't match the input type or the data type. The data type is an integer, so remember that. I had declared the enumeration outside before the main function. It is also equally okay to declare the enumeration inside the main function. And there are some differences that we will talk about later of why you would declare something outside the main function versus inside the main function. So anyway, this program works exactly the same if you declare inside the main function. So now let's look at the textbook example, the game of craps. I looked at the program. The program was kind of large, and I decided to go ahead and take a stab at doing the flowchart, because flowcharts, if you can flowchart what's happening in the code, you can understand the code a lot better. Sorry, this gets a little messy. I am handwriting it. So you start with an initialization. You perform some action, which was roll dice. Roll dice actually calls a function out here and returns the sum of the dice. And then we do some tests. Is it 7 or 11? Then you win. Is it 2, 3, or 12? No, then you lose. And so it's some other number, and then we just continue. So this whole thing here, it actually looks like it should be, of all this whole thing here, this looks like a switch statement to me. This must be a switch. I'm sure that that's a switch. Roll dice over here is a function that I have to create. And then you come down here, and if it's not this case and it's not that case, then it's continuing, and you have to then it's called the point value, the point, and you have to try to make point. So let's say point was 5. You're going to roll your dice again. If you get a 5, you win. If you don't get a 5, you have to say, is it a 7? If it's a 7, then you lose. But if it's not a 7, you can roll the dice again. And I see some kind of a loop structure happening out here in the program. So that was my my attempt to flowchart it. It is worthwhile for you to flowchart it. But here's actually the program now. Let me show you the program. Whoops, where did it go? So I'm going to be rolling dice, so I know I need the standard library because I will want to use the rand function. I want my game to not be fixed, so I do want it to actually have truly seed it different every time I play the game. So I'm also going to use the time function for seeding. This next line here, let me make it a little bit bigger. Sometimes I make the letters big and you can't see the whole program, and then so when I make the letters small enough to see the whole program, and then you can't read it. So I create my enumeration. It's called status. So there's 3 things that can happen in your game status. You either won, you lost, or you're continuing, so you're trying to make point. And then we need a function called roll dice. Roll dice is going to return an int value. It's going to be the sum of the dice being rolled, but it doesn't have any argument, so roll dice has a void right here because there's nothing you are passing to that function. So every time I call roll dice, it's going to return the sum of the dice, and it will use a random number. So now I'm going to enter the body of the game. I'm entering the main right now. First of all, I initialize the random number generator thing by srand using the system time on my computer. Here I'm making my different variable declarations. So point, the point is the dice value that you have to match. Here I make a variable called game status, which can contain one of the values of the enumeration, either continue, won, or lost. And then I declare a variable called sum, and sum comes from rolling the dice. So I remember roll dice doesn't have any argument right here, but when I call roll dice, it's going to return the sum of the dice roll. So once I have sum, I have to say, is it 7, 11? Is it 2, 3, or 12? Or is it some other number in between? So this is where I use the case structure. See, if its case is 7, it's a winner. Case is 11 is a winner. Notice I didn't do anything with case 7. Or case 11. I match either one and I get the game status is 1, and then I break out of the switch statement. Or maybe you lose on the first roll, so that's case 2, 3, or 12, and in any of those cases I get game status is lost. Remember, I'm setting the value of game status is lost, so it's actually game status, or the enumeration is continue, won, or lost. So continue is a 0, won is a 1, and lost is a 2. But anyway, I can refer to it not by 0, 1, or 2, but by the name associated with it. So won or lost. So if I didn't win or I didn't lose, then I must be trying to make my point. So the game status is then continue, and your point is whatever that current sum is. And I went ahead and had the program print it. And while I'm in continue, I have to keep rolling the dice. So if the game status is continue, I'm going to roll the dice again. I'm going to say, is it my point? If it is my point, I won. Else it's not. Else I rolled a 7, I lost. And if you win, you get that the player wins, else you get the player loses. So this is embedded in a while loop, so the while loop, yes, goes for between here and here. Make sure you see the alignment. So this while loop will continue. We will continue to roll the dice until either you have a win or a lose. So that's the overall game. Finally, down below the main is where you did your function definition, and so this is where I define the function roll dice. As I said again, there is no argument over here, parameter, but it is going to return an int value. This is where I use my random number generator. So dice 1, roll it, dice 2, roll it, print the value of dice 1, dice 2, and the total of dice 1 and dice 2, and the function returns that total of die 1 and die 2, and that's the value, that's the integer value that's returned. So I guess I'll go ahead and demonstrate the function, demonstrate the program running. So here I just compiled the program. There it is, my first roll. Player rolled a 12, the player loses. So it's the game doesn't, it's one shot at the game. It doesn't continue indefinitely. You'd have to change the code to make it continue indefinitely. So I can play again. Here they rolled an 8, so point is 8. Then they rolled a 4, didn't match point, so they continued. Then they roll a 7, 7 loses. So now I learned how to play craps. So next ran the game again. They rolled an 8, point is 8. Player rolled a 6. Didn't match. 11, 3, 5, 6 kept not match. They kept not getting an 8, and so player loses. So I could learn a lot from this game. 7, player wins. Nice. Okay, I gotta quit playing the game. And I'm not even going to talk about how you bet on this game or what the craps table looks like. That's above my pay grade. Okay.